Do the cover-up method, divide by 3. Do the cover-up method, divide by 2. And so on. You guys remember that? Okay, so again, I'm going to show it up here as well. So for this, x equals, well, divided by 3, and I get 6. Let's actually go right to our graph and plot x equals 6, which is right there. Okay. Also, what does y equal? Well, let's cover up x. What does y equal? 9. So let's go plot 9 on the y-axis. And then use my straight edge to connect them. Again, try and be as accurate as you can. And shade it. Okay, so again, it's just easier to graph and shade. So I plug in 0, 0, and I get 0 is greater than or equal to 18. Is 0 greater than or equal to 18? No. So what does that mean I do? I shade away from 0, 0. Here's 0, 0. I don't want to go towards it. I want to go away. So it's all of this stuff up here. Now let's grab the other one. And again, I'm using some different colors here. X and Y, well, what are they both equal? Right? If I cover it up, I get 10. If I cover it up, I get 10. Right? So they're both 10. And that's the reason why I'm doing this one, because it looks a little different. We put a y at 10, x at 10, and connect those dots. Somebody's going off on it. Alright, so we get here. I plug in 0, 0. I get 0 is less than or equal to 10. Yep, that's good. So the red one actually gets all shaded down. And then, again, x is greater than or equal to 0, y is greater than or equal to 0. That just means it's in the first quadrant. That's all we're dealing with anyway, so I'm not worried about really doing that. Can you see the double shaded region? Yeah. Kind of looks weird because there's no real points of intersection, but there are. Let's shade in this middle part. That's our double shaded region right in the side there, right? Make sure that stands out for you. I have a tendency to draw a second line, so I have to outline it first. To get my 6-year-old in here, you can color better than me. Can you still see points of intersection here? The corners? What are the corners? Can anybody come up here and point to a corner? Is that a corner? Is that a corner of my region though? Because this is my region, right? So that doesn't, 0, 0 is not going to be one of them. What about that? That's a corner of it. So is that. So is that. So is that. Nothing else down here matters because it's not in the shaded region. We needed the double shaded region right here. So our vertices are based right here, right here, right here, and right here. So I'm going to label those vertices. Again, be careful of your x and y's. This is 0, 9, and 0, 10. 6, 0, and 10, 0. And again, I got those right from the picture. Plug them in. And again, I'm going to kind of skip the first step I did up above. I just showed you I'm plugging x into x and y into y. So 0 plus 18, because 2 times 9 gives me 18. 0 plus 20 gives me 20. 12 plus 0 gives me 12. And 20 plus 0 gives me 20. Uh-oh. What happens when you get 2 answers?
You don't have to.
Why not?
Because we're minimizing.
Ah, see, I was trying to get you. Right? There's not 2 answers here because it asks me to minimize it. Which point gives me the minimum? 12 at the minimum, right?
Oh.
So minimum would be the smallest value, which is at 6, 0. So x equals 6 and y equals 0 at 12. Now, if I did ask you to maximize this, there would be 2 answers. You would say both 0, 10, and 10, 0. would maximize this. We're going to see that happen on one of your homework problems, not today, but in the future. But for right now, we just want our minimum, and it's at 12. Okay? Questions on this? How many of you, after 2 of these problems, feel pretty decent about what we did just in this page? Okay? Okay, good. All right, next page, we're going to get to tomorrow. This is what linear programming is really all about. We're going to talk about how to write our inequalities from the information given. And it's talking about ivies and mums. If you can't tell, this is ivy. Can you see that on your paper at all? Not so much. You can come out with a copy real good. Okay. All right. So there's that.